Hello everyone and welcome to the AutoCAD video. My name is Abdo, and in this video I wanted to show you like a few tips for what you can expect when you're drawing a bridge in AutoCAD. So here we have a simple span bridge that I'm going to show you the expected drawings that you need to do in order to show the properties and the dimensions of your bridge. Okay, so now I am in my layout, so I will go to my model and show you. Okay, so we have a road. This is the road, and the cars are moving like this way. And it's like a four-lane road, and we have another road that is going to pass from underneath our big road. And we want to do a bridge over here to allow some space so for the underneath road to pass by. Okay, so we have here a plan view of our bridge, and as you can notice here, we have cutting lines so that and those represent that our road is continuing on the left and on the right. And this is the space for our bridge. It's a bridge that is going to be 20 meters, and this number indicates a location on the road. So this indicates that our bridge is going to be at kilometer number 3, 500 meters. Okay, and this is the road underneath it, and the white lines over there are our retaining walls, and after that we have our soil, and those lines show you that we have like our road. Let me show you the cross section. We have our road, our cars are going this way, and then we have concrete sloping here that is holding the soil from underneath our road. And the slope of the concrete is 3:2. And as you can see here, this is our indication. This is like 3 horizontal and 2. And this is a sloping concrete. And usually in concrete, we have to like catch it like this. And then we have soil. We also have to make a hatch. And the road has a slope. It goes from the middle to the right and from the middle to the left. And we have a shoulder that has to be on the roads. We have the yellow lines, and this is the carriageway for the cars. And the width of the road is 21 meters, and we have a meter on the side and a meter on the side for safety. And this is our shoulders. We have one in the middle, and we have our concrete barriers. We have one in the middle and one on each side. Okay, so this is a cross section of our road. And the most important thing that you need to take care when you're drawing something like this is that all your views are correct from each view, and I will explain that later. Okay, and here NGL means the natural ground level, and this is like shows you that our concrete, which is folding, is going to extend underneath natural ground level. Okay, so this is our road, and we have here a plan view. Okay, and we have this is the road, and this is the other road that is going to pass. And if we have an elevation, meanwhile, like looking in this direction, like this, we're looking in this direction, we're gonna have an elevation. So this is our bridge. It's a simple span bridge, and the bridge is made of a slab, and then we have T-girders or T-beams, and this is the road that we have here, which is this one that is passing from underneath. And these are our abutments, and those are called approach slabs. And here we have our retaining walls, and these lines represent that we have a slope of soil like this, okay, that is being held by our retaining walls. And these white things over there, we do them with a dotted or like a dotted line. They indicate that we have insulation that we need in order to protect the concrete from the water in the soil. And this is our road underneath a bridge. And as you can see, a span here is 20 meters. And as I said, you have to make sure that all your views are representing the right conditions. So here, our bridge is 20 meters in our elevation. Here also is 20 meters. And here is our axis, and you need to have your axis in order to show the beginning and the ending of your bridge. And some people will draw the axis at the center of your bearing, which is holding a bridge. And as you can see, this is a neoprene bearing. And other people will draw the axis here at the expansion joint, which is connecting between our bridge and our abutment. Okay, and those are the concrete walls, the concrete slopes that are holding our soil. And the small circles over here indicate that we have piles that are holding our retaining walls and our abutment. And we have a concrete layer that is there for like protection, to protect our reinforced concrete from the water in the soil. And this is usually plain concrete. Okay, and as you can see, everything is drawn on a separate layer. Like the concrete is on a layer, the dimensions have to be on a different layer, and I have to make sure that in my layers I'm completely accurate, especially the line weights, because when I'm printing, my drawing is going to look better. And here the 3:2 indicates that the slope of your road like this. Okay, so like this is a kind of like an overview of your bridge, and this is going to be our first drawing. And as you can see here, I'm using my layouts. Okay, so the second drawing represents a concrete of your bridge. So this is our bridge that we took, and now we are focusing on representing the concrete dimension. So this is called a diaphragm, and this is an expansion joint, and it should be move over here a little bit like this, and it has a 50 millimeter width, and this is our approach slab. So the approach slab is kind of a transition slab because the car is going to move in this direction. So this slab is kind of transitioning from concrete to soil, because at here the car is moving over a concrete, and then here it's moving over a well compacted soil. Okay, and here's our insulation, and we have to write as per approved specifications to make sure that we are according to the specifications. And here we have well compacted soil according to geotechnical, and as you can see, everything is written in capital letters and should use capital letters. And here is the title of our drawing. Of this drawing is going to be an elevation. Its scale is going to be 1:75. Okay, and here is the it's a PC 100 millimeter thick concrete, and PC means Portland cement concrete, so it's not reinforced concrete. And the concrete is drawn in green. Okay, and this the dimensions of our beam. So the first layer here is our concrete slab, and this we have a T-beam. Okay, so our cross section is a T-beam. So if you look from the side, you're gonna see this thickness, and then you're gonna see this thickness, which is our RC slab. So this is the flange of our beam, and this is the web of our T-beam, and this is our cross girders. Okay, so this is our elevation view. As I said, you need to make sure that everything is represented correctly in all your views. So this is our elevation, and this is our cross section. So the cars are moving this way, and as you can see, you have to draw the dimensions, which is the spacing between your beams, and you have to also indicate the name of each beam, because after that you're gonna have if you have different dimensions for each beam, when you draw the beam detail, you have to indicate its name. And here's our slope. Okay, and as you can see here, our beams are kind of like moving in a stairway to to uh, um, to help in having our slope over here, so that for our drainage system, to make sure that we have a drainage system, and we indicate the dimensions. And this is our handrail. As you can see, it's like a steel, and we have a concrete, and this is like a small sidewalk, which has a dimension of 500 millimeter, and this is our concrete, or this is our asphalt layer. And as you see here, we indicated that it's a 100 millimeter asphalt, and then 150 millimeter cast and seep. So you need to be really delicate in indicating everything. And as you can see, this is section number C. So if you go to your plan view, and here's our plan, like if we are looking from our top, and this is our section C. This is how we represent our section. And if you want to draw a detail to show some specific details, you can use like a dotted or like a dashed line like this, and indicate that the name of the detail number 1, and everything is in capital. Okay, and this section is going to be scale 1 to 50, so everything is going to be in double scale. And this is a plan view for our bridge. So as you can see here, these are our girders, our beams. So we have here the center, or let me show you. So this is the spacing. So this line indicates the width of your beam and how it spans. So, and this is the spacing from the center line of our beam to the other center line. And as you can see, the center lines are blended by a long line, a short line, a long line, and a short line. And everything in this drawing is drawn in dashed because we have an asphalt layer. So if I took a plan view like this, which is section number B, which I have here, I have I'm gonna see everything underneath a concrete. So anything underneath a concrete is gonna be in dashed lines. Okay, and those are my bearings that I have, which are these ones. Okay, and this is the dimensions. So I have this line, and then I have this line. So this line has to be drawn as a dashed line, as you can see here. Okay, because it's not going to be the first thing I draw. Okay, and if you don't have space in your drawing, you can take a section and indicate it by this line. Okay, and this is our span. So our span is from the axis to axis 20 meter, and our girder is 20 meter and 800 20 meter and 8 centimeters. Okay, so you also have to make sure that you're indicating your sections correctly. Like this is section A, which is our elevation, and this is section C, which is our cross sections. Okay, and it's important to indicate that you have a slope over here. So to indicate that the bridge has to go from left to right like this, it has to have a slope. And this is the thickness of our concrete slab of our 1500 150 millimeter cast in situ reinforced concrete slab, and then we have our beams. Okay, and as you can see here, we have a very small spacing between our beams, so that we can have, so when we pour our slab concrete during construction, it sits on the beams. Okay, and this is, and in bridges, this half is totally separate than this half. So the loads that are happening here are not gonna affect this side of the bridge. As you can see, they are totally separate from each other. And we have here a small sidewalk, and here we have like a concrete barrier so that it protects the cars from going to the other side. And our beams are RT beams. So let's see detail number one. Detail number one, which is this one. And in this detail, we indicate the spacing between our beams. We indicate that these are precast beams, meaning that they will be done in the factory and they will come on site and we're gonna install them on site. And we have to indicate the depth of our beam according to our design and the thickness of our flanger. So the total height of our beam is almost 1 meter and 100. It's almost 1500 millimeters. 1150. I'm sorry, 1250 millimeters. Yeah, because this is 150, this is 100, 1100. Okay, and we also have a detail for our end diaphragm. Some people call it diaphragm, and some people call it cross girders. Okay, and you need also to draw an elevation for your beam. So, for example, this is a typical beam elevation. As you can see here, we removed the thickness of our slab. So in our normal, if we did an offset, it's gonna be like this. So this is the thickness of our, but here we are drawing our beam only. So I need the thickness of the flange and the depth of the web and the cross girders only. And with every drawing, you have to write its name, you have to write its scale and everything. Okay. So, and these are the plan views of our beam. And as you can see here, when you're doing a precast beam, you have to leave this part empty, this part empty, and then when you go on site, you pour the concrete here and here to connect a precast slab to your diaphragms. Okay, and as you can see here, we indicate the name of each beam because they are a little bit different from each other. So we need to indicate them. Okay, like this beam is the width of the total width of the beam is 1730, and here it's 1725. And even if it's a small difference, you have to draw on other sections because to make it easier on the contractor during construction. Okay, so so if we go to our layout, we have our main view of our bridge. We have a top view and then elevation or a planned elevation. And then we have our concrete drawings. We have a cross section, a detail for our beams. And as you can see here, everything is according to scale. So this is a scale 1 to 25. So it means everything is multiplied by 4. So in your model, you draw it by one. But when you come here to your layout, you multiply this by 4 to indicate, to make it bigger to show the detail. So everything is according to our scale. Okay, and some people might draw because this is a bridge, like one bridge on a very huge road. So if we go like here, we will see the number of bridges that we have on this bridge, and our bridge is in bridge number 2, which is over here, which is the beginning of our road. Okay, and this has the our beam details. This is a detail for beam 1, a detail for beam 2. Okay, and this is your title box. So you need to, so for example, here you need to like write the name of your drawing and write in the scale box as shown, and maybe here you write the designs. And here, if you are drawing revisions, you can say that this one is revision 0, the other one is revision 01. Okay, so this is what you mainly should expect in a concrete bridge drawing. Okay, so number one, you have to make sure that all your elevation, plan views, side views, section all have the same dimensions. And then when you move on, you also have to make sure that your axes are in the right location. You have to make sure that you're indicating the name of each element in your bridge, so that, and you have to, if you have like different beams, and so like this is like one type of a concrete bridge. Like, there are many types. This is called reinforced concrete T-beam. Okay, so it's a reinforced concrete girder bridge, and our girders are T-beams. Okay, you have to indicate the width and everything you need. Okay, and make sure that everything is drawn on a layer. Let me see if it's gonna work over here. Okay, layout. Let me see. I have my layers are saved on something called Roca, and I want my drawing to be an A3, and then window to indicate the drawing that I want to, and then my layout, my title box is in the same dimensions of an A3. Okay, so then let's see how it's gonna look. So this is outside like your box, so you have to make sure that your dimensions here are correct. So you have to say fit to paper. You see over here we didn't have this selected. Now we have it fit to paper, and then you select it, and then you print it. Okay, hope this time it works. Preview. Yeah, and as you can see here, because we draw everything on a different layer, everything is correct. We have our concrete, our hatching, everything is correct. And this is an A3. So our drawing is going to be printed on A3 paper. And let me explain this a little bit more. So depends on your contract or the office that you're working in. We have different types of papers, and you have to make sure that your title box is in the same size that you are going to print, so that you don't have any mistake in the scales of your drawing. Okay, because if you didn't do that, AutoCAD might reduce the stuff in order to make it fit in one paper. Okay, thank you so much, and hope to like help you in any other videos. Okay, thank you.